This is going to be the title video for a series that of problems that I'll be working on to prepare myself for the final. It's going to come up in a few months, but I'm going to start working on some basic problems just because I want to have fun and I love number theory. So in this playlist, this is the first video on the playlist. I'm going to be talking about Legendre symbols. Actually, I'm going to be solving a bunch of them as a test. So really, there's going to be this first video in which I discuss what's behind what I'm doing in each one of the examples, because when you see the examples, I'm going to try to recreate what would happen if I was taking a test. I'm actually going to assign myself a random Legendre symbol with 2 primes, so it'll be P over Q, and I'll just do it right there and then I'll check if I got it right or not. The only videos that I'm going to upload are the ones that I got them in which I got them right. I usually have like an 80% hit ratio with Legendre symbols, so I should be okay. But anyways, in this video, which is the first one on the playlist, I'm going to be talking about what they are, how Legendre symbols come about from quadratic residues and non-residues. I'm going to do mod 7 as an example. I'm going to show some of the rules for Legendre symbols, discuss quadratic reciprocity because that's really your trick for solving the Legendre symbols. And then I'm going to do a few examples in this video, very simple examples, because the ones that I'll be doing in the playlist will be much more complicated examples. I just want to test myself. And then of course, what follows this video will be the actual me working through the Legendre symbols. Yeah, okay, so let me erase this. This is my early setup. I think I'm going to try to make it better and better as I progress in my little YouTube career. So the whole thing about residues and non-residues is explained by this formula. And so in this case, when you solve for a prime, any of the values you get that solve this equation are your quadratic residues. Okay, that's really how it's defined. If for a given number, for a given prime, you never pull any A's for those values, they're going to be quadratic non-residues, and I will explain immediately. So for example, let's do mod 7. Okay, so 1 square mod 7, notice that I'm squaring here, is going to be 1. So that's that A. Okay, so right there, this is your first quadratic residue mod 7. 1 is a quadratic residue mod 7. Actually, 1 is a quadratic residue of every prime, because no matter what this prime is, you're always going to get 1 when you square, and it's always going to be less than the p, so the mod is never going to go over that prime. Okay, so then 2 square, I'm just going to write these down. Okay, they're all going to be mod 7, so this is going to be 4. Okay, this is going to be 9, but 9 mod 7 is 2. Now notice what happens with quadratic residues, which I happen to love. I already know what the values are for the other 3 because they climb and then they go down. I already know the answer. And if you do any mod, you can do mod 79 or whatever, and I know 79 is a prime. You're going to have this staircase thing where you're going to go up and you're going to come down. Sure enough, let's just work it out and you will see what I'm talking about. 16 mod 7 is 2. Right? Because 16 minus 14, it's 2. Then 25 mod 7 is really 4 because you subtract 21, right? 7 divided 21. Then 36, of course, 35 is 7 times 5, so you get 1. So right there, you see how the quadratic residues of 7 work. Now remember that we obtained 1, 2, and 4. Okay, these were the solutions to x squared a mod p. Well, in the Legendre symbol nomenclature, this really means 1 over 7 is equal to 2 over 7 is equal to 4 over 7 is equal to 1. Now, these are the quadratic residues. then the quadratic non-residues are all the other ones. Residues are all the other ones that we didn't pull, if you will. So that would be 3, that would be 5, sorry about that, 7, and that would be 6. So these are non-residues, mod 7. And there's a little theorem that says that there are p minus 1 over 2 of each of these categories. Sure enough, p minus 1 over 2 is 7 minus 1 over 2, which is equal to 3. So there's going to be 3 residues, and then, I guess I should have written them, 3, 5, 6, 3 non-residues. Alright, so that pretty much covers what a residue and a non-residue is, and what a value for a Legendre symbol is. And I forgot to say this is equal to 1, so I'll redo them because I forgot to show that. So equals 1. These are Legendre symbols. Okay? And then 3, 5, 6, these are non-residues. Alright? So those are the Legendre symbols mod 7. Okay, so now that I've covered that, I'll cover a few simple rules for Legendre symbols. So for example, if you have a number that can be a composite number, let's just do AB. And let's just do 7 actually, let's just jump into examples. Let's just say that A equals 2 and B equals 3. Now we already know, okay, we already know the answer to this one. This one is 6 over 7. We already just showed that it is a quadratic non-residue modulo 7, so it is minus 1. Alright, so what does this equal? This equals 2 over 7 times 3, the Legendre symbol, 2 of mod 7, and the Legendre symbol, 3 mod 7. Alright, so I think I'm going to do a little bit of a shortcut there to show how these work. Alright, so then there's 2 ways to solve, for example, 6 over 7. You can solve it by breaking it out into 2 times 3, okay, and then everything here is a prime. You want everything here to be a prime, so when you finally solve them. Or you can actually say that 6 over 7, the Legendre symbol, is actually negative 1 over 7. Okay? And then what I'll do is I'll erase this, and then I'll go back and show them to you all. Using toilet paper because I still cannot find my eraser. Okay, so we were trying to do the Legendre symbol for 6 over 7. Now some basic formulas for Legendre symbols are 1 over p, 1 and a prime, is always 1. Negative 1 over p is negative 1 to the p minus 1 over 2. And then 2 over p is equal to negative 1 to the p squared minus 1 over 8. Okay, those are your basic rules that you're going to try to remember for your exam. And the way that I'm going to solve these problems, I'm going to assume nothing is given to you in the exam except the Legendre symbol. Okay, so knowing this, let's go ahead and solve 6 over 7, and we can solve it both ways. We can solve it as 6 over 7 equals 2 over 7 times 3 over 7, or we can solve it as negative 1 over 7, which is just that, right? And 7 minus 1 over 2 is equal to 3, so it's negative 1 to the third power, which is negative 1. We already knew this. We already know that 6 is a non-residue mod 7. Now, to solve this right here, we're going to need a little something else, which is really at the heart of number theory, and really is, I think, one of the most fun parts of the course that I'm taking, which is the quadratic reciprocity equation, okay, which can be written as, of course, p q are distinct primes is equal to negative 1 to p minus 1 over 2 q minus 1 over 2. Now, and I've mentioned this in other videos when I've talked about my progress in the class, it's the whole product. It is not this. It's not. That gives you completely different results, and they're wrong. Alright, so you got to remember that. Now, the beauty about this is that if you multiply an even number by anything odd or even, you get an even number. But if they're both odd, then you get odd. Alright, so this power is only going to give you a negative 1 when both of these numbers are odd in the p minus 1 or q minus 1. So I'll give you an example. 5 minus 1 over 2 is 2. So that's going to give you 1. 3 minus 1 over 2 is going to give you 1. Negative 1 to the 1 is negative 1. Alright? So that kind of sets it up. Now, the trick that we're going to use to solve all these Legendre symbols is we're going to flip this symbol to the right. And so really we're going to work with this formula this way. Okay, that's how we're going to work, because we multiply both sides by q over p. Okay, and this became 1. So that's how we got it to go to the other side. Alright, so that was the trick for that. So now I think we're ready to do the Legendre symbol 6 mod 7 using all of the tools that I've described previously in this video. Okay, so this one is negative 1 to p squared minus 1 over 8. This one, because 3 minus 1 over 2 is equal to 1, and 7 minus 1 over 2 is equal to 3, we have odd, odd. So when I flip this symbol, I get a negative 1. Now, 7 mod 3 is just 1 over 3, right? And that becomes 1. And this is 49 minus 8, minus 1 over 8, which is 48 divided by 8, which is 6, which is even. So this is also 1. So all we are left with is minus 1. So this is 1. And then when we flip this, we get a minus 1 and a 1. Now, one of the tricks that you're going to see when I try to solve my much harder Legendre symbols in the playlist is that for very complicated Legendre symbols, you're going to really wind up doing something like this. Really, after you do all the calculations. And the mistake always is to forget one of these. That's just how you get it wrong. And that's how you're going to get a 1 where you should have gotten a minus 1, or a negative 1 where you should have gotten a 1. Alright, so I think I discussed everything. Did I also mention, I think I forgot to mention one little detail, which is the square. So squares in Legendre symbols are always equal to 1. Okay, so for example, the Legendre symbol 4 over 5 is 2 squared over 5, which is 1. And that's another technique that you're going to use. So for example, if you wind up with something like 8 over 79, okay, and this is, and I'll also add another little trick in here that you'll see when I try to solve these Legendre symbols. So I'll do this one as an example. So this is really 2 squared over 79, 2 over 79. This is 1. Now, a little math trick that I use for this is 79 squared is equal to 80 times 80 minus 79. So this is really 6,400 minus 159, which is 6241. 6240 divided by 8 is 7, 56, 64, 80. It's even. This is also 1. 8 over 71 is 1. So there you go. And I hope you enjoy watching me torture myself doing Legendre symbols. And of course, the key always is to have fun.